Alright, so this is do now number 8. Number 1 is asking you for the domain. So problem A, f of x equals the square root of 6 minus 11x is similar to ones you've done before. Remember, if it's a radical, if the x is inside a square root, then we know that the radicand, this part right here, has to be greater than or equal to 0. Okay, so that's how we're going to set it up. So it's going to be 6 minus 11x greater than equal to 0, and then you solve for x. So then you have negative 11x. We subtract 6 from both sides of the inequality, so you get negative 6. And then we divide by negative 11. So when you divide an inequality by a negative, you switch the inequality to the other side. So 6/11. So x is less than or equal to 6/11. So remember, on a number line, here's 6/11. Less than or equal to is this way. So when you write your interval notation, you go negative, you always write from left to right, negative infinity to 6/11, bracket, and then parenthesis on this. Okay, for letter B, since the x in the numerator is not inside a square root or a radical with another even index, then we can ignore it. It could be all reals. In the denominator, I have x's, and I just have to make sure that this expression right here is not equal to 0. So I have to make sure that x squared minus 3x minus 4 does not equal 0. Okay? So this is a quadratic, so remember, you've learned how to factor this in the past. So factors of negative 4 that add up to negative 3 are negative 4 and 1. So this quadratic could be factored as x minus 4 times the quantity of x plus 1. Cannot equal 0. So then you ask yourself, okay, what would make this one 0? Well, if x was 4. What would make this one 0? This one right here. If x was negative 1. So because it can't equal 0, then you say that the domain would be all x such that x cannot equal negative 1 and 4. Now if you write it in interval notation, you could, it's just a little longer. You would have to say from negative infinity to negative 1, union negative 1 to 4, union 4 to infinity. Okay, so that's the same thing. These two things are saying the same thing. Okay, letter C. You see a radical, okay, for letter C, but notice that the index is odd. So that means that I can have negatives in here, no problem. So there are no restrictions. So the domain for this one is all reals. Alright, so for number 2, excuse the picture, but the only thing that it's not square. What I'm quizzing you here, what I'm testing here is if you know your parent functions. You have to know everything in that booklet from memory. Okay? So the cubic function is 0, 0. I know the graph is kind of crooked. And then it would be 2, 8, like somewhere up here. So it goes like this, and then negative 1, negative 1, and negative 2, negative 8, like this. That's a cubic function. The square root function, 0, 0, 1, 1, 4, 2, so it goes something like this. The rational function, it's not the rational squared, so it's 1, 1, 1 half 2, 2, 1 half. So it's the one that has two branches, one in quadrant 1 and the other one in quadrant 3. So negative 1, negative 1, negative 2, negative 1 half, negative 1 half, negative 4. So remember, it never touches the x and y axis. It gets very close. And that's all there is to this one. Alright, so number 3 is a piecewise function. You have to graph it and then state the domain and range. So it's made up of two pieces right here, and the break happens at 2 when x equals 2. So that's where your dotted line goes, your vertical dotted line. Now again, the picture isn't square, so it looks a little bit crooked. It's the best I can do at this moment right now. So there's the line that separates the two pieces. So on the left side over here, less than 2, I'm going to graph -4. I'm going to graph y equals -4. On the right side, on this side, I'm going to graph y equals -x plus 8. Okay? So then you find your ordered pairs. A lot of you are asking on how we get those points. Basically, we look right here. Replace the 2. Well, there's no x here, right? Because this is a horizontal line, y equals -4. So the point that I have here is going to be 2, -4. And it's going to be open because it's less than. And then, let me pick a different color. Let's say yellow. For the second piece, it says greater than 2, so that's greater than or equal to 2. So that's going to be a closed dot. Replace the 2 right here, so -2 plus 8 is 6. So 2, 6 is my point. So I'm going to graph purple on the left, yellow on the right. Okay, so on the left side, I have an open dot on 2, -4, about here, and it's a horizontal line, y equals -4. On the right side, I'm going to graph y equals -x plus 8, starting at 2, 6, with a closed dot. The slope is -1, right? -x plus 8 is -1, so that means that it's going to cross. Now the graph, the picture is like not, it's not straight on, so it's going to look kind of weird, but it would cross at 8, 0. Negative slope going this way. Okay, so domain. So that's a graph. Domain. As you go from left to right, you're coming this way. There's points all the way across. Even though there's a break right here, there's a point up here at x equals 2. So the domain is all reals. Whoops. The range, you go from the bottom to the top. So you come from bottom to top. Yes, there's a -4 here and it's by itself. But remember, this line extends forever, right? So if I go from the bottom to the top, I'm going to have points because this line goes forever. So I'm going to have points all the way up to here, up to right here, where y equals 6. Above that, there's no more points. They're gone. So it's from -infinity to 6. The dot up here at 2, 6 is closed, so that's going to be a bracket, and then there's your parentheses. Okay, and that's number 3.